Hi everyone, my name is Polly, and today I'll be going over FRQ number 6 for AP Chemistry exam review. This is from the 2024 exam, and let's get started. So over here, this is question number 6, and it goes, at elevated temperatures, NO2 undergoes decomposition in the gas phase, forming NO and O2 as represented by the following equation. And it goes, a scientist measures the change in the concentration of NO2 over the first 100 seconds of the reaction at 546 degrees Celsius. The scientist uses the data collected from the experiment to generate the following two graphs. And for letter A, it goes, determine or explain how the graphs indicate that the reaction is second order with respect to NO2. So every time, no matter if it's a multiple choice or FRQ type question on the AP Chemistry exam, if they ask you something about what's the best fit graph for a order reaction, you always want to look for the linear graph. If something is plotted and it's linear for a order of reaction for a equation, that's your most valid one. Notice how this one it's curved. That's bad. We don't want the curved one. That means that's not the right one. So actually, if you go to your reference table, which is over here, and you go to kinetics, it's going to tell you exactly how to do it. They're not going to tell you explicitly which one is which, but it's pretty easy to figure out. So this first one, that's your zero order um, equation. This next one that has natural log, that's your first order, and your third equation on the list is second order. So they are in order. As long as you know that, that honestly should be all you need. And as we go over here, we notice, okay, we have 1 over the concentration of NO2, and that's the most linear. So that is going to be second order. So I said the most linear graph is where 1 over the concentration of NO2 is plotted on the y-axis, and that is the most representative of second order. That's all you need to say. For part B, it goes, a certain point in the reaction, the rate of disappearance of NO2 is determined to be 6.52 times 10 to the negative 7 m over s. Determine the rate of appearance and m over s of O2 at the same point in the reaction. So with this, you could honestly just use the mole ratio because this is just basic stoichiometry. So notice that for every 2 moles of NO2, you have 1 mole of O2. And you're actually just solving stoichiometrically. So it looks kind of funk with the way I typed it out, but when you write it out, it'll probably make a lot more sense. So it's 6.52. That's what you start with. That's your ooh, that's your starting value. 6.52 times 10 to the negative 7. So we start with that, and then we have times 102 moles over 2 moles of NO2. You cross cancel, you multiply, and you should get 3.26 times 10 to the negative 7 m over SO2. And make sure you keep your units, and that it should be 3 significant figures as seen right here. Moving on, letter C. NO2 is a molecule that contains an odd number of electrons and can be oxidized from the NO2 plus ion. In NO2, the unpaired electron is presumed to be localized on the nitrogen atom as shown in the Lewis diagram in the box on the left. And for letter I, it goes, in the box on the right, complete the Lewis diagram for NO2+. Be sure to show all bonding and non-bonding electrons. So the first thing I think, okay, what group are all these in? So oxygen is in group 16. Bam, it has 6 valence electrons. Nitrogen has 5, so it should, in theory, have 5 valence electrons. So my first thought would be, okay, get oxygen to 6. And you could first kind of start by drawing 6 dots surrounding oxygen, but I just kind of skip that step. If you need to do that and then erase later, that's totally great as long as it works for you. And then remember, this is a positive ion, which means you have 1 less electron than usual. So when we're trying to go for um, nitrogen, even though it should have um, in theory 5, it's going to have 4, and that's fine. Remember, you can always think of formal charge. I would recommend reviewing that to understand your Lewis structures a little bit better because part of it is kind of just guessing and checking. But I would definitely recommend reviewing your Lewis structures and your formal charges. I don't know, I think it's either chapter 8 or chapter 9 if I remember clearly. It's one of those chapters towards the end of the year. And yeah, so nitrogen should have 4 around them, and then oxygen should have 6 around both of those too. For II, it goes, a student makes a claim that the bond angles in NO2 and NO2 plus are different from each other. Do you agree or disagree with the student's claim? Justify your answer. So I would agree with this because, as you can see, lone pair over here, no lone pair over here. And so we would say agree, and you would say that the lone electron in the left diagram on the nitrogen means that the bond angle there will be significantly less due to electron repulsions. That's your key term right there, electron repulsions. So that would make it less than 180 degrees, unlike the bond angle on nitrogen in the right diagram that is 180 degrees and linear. So this is a linear molecule. Everything is 180 degrees. Bam, right? That's your big angle. Here, this lone pair is kind of initiating repulsions that are condensing the atom and, descaling those angles, those bond angles, making them smaller than actual, making it more of a bent angle. So you can probably think of SO2, H2O, same kind of vibe, right? So because there's that lone pair, the angles will be smaller. And that's it. Hope that was helpful. Good luck studying for your exam.